Hi, welcome to my video on the system of linear equations, two variables, solved by graphing method, part 2. Part 1 was when we had the two equations that solve for y, but in this one we're going to solve the equation for y and then graph. So let's label this equation as number 1 and this equation as number 2. So let's write down equation number 1 and solve equation 1. This is 6 for y. Negative 3y equals negative 2x minus 6. Remember, we're writing the equation as y equals mx plus b, where m is the slope and b is the y-intercept, so the x moves over to become a negative. We divide by negative 3 because we want a y by itself. Negative divided by negative is positive, so it's 2/3 x plus 2. So in this equation we have a slope of 2/3, and we have a y-intercept of 2. So equation 2 is x plus y equals negative 3. And we solve for y, the x moves over to become negative, so we get y equals negative x minus 3. So that equation has a slope of negative 1 and a y-intercept of negative 3. And notice the slope is negative 1. Let's put negative 1 over 1 because we're going to graph it. Let's graph the first line. We got a y-intercept of 2. So there's y is 0, so the y-intercept of 2 is right there. And the slope is 2 over 3, so that's up 2, right 3. Up 2, right 3. So we'll draw the line going through those 3 points. Normally when you graph, we hope most times that if it's going to intersect at a point, it'll intersect right on the coordinates. Now let's graph number 2. The y-intercept is negative 3 and the slope is negative 1 over 1. So the y-intercept is negative 3, 0 is here on the y-axis, negative 3 is 1, 2, right there. And the slope is negative 1 over 1 is down 1, right 1. Down 1, right 1. So we'll draw the line going through those 3 points. And we line it up. And again, graphing is great here because it hits right on a point. And there's the point that it hits on. And the x value is negative 3 and the y value is 0. So the solution is negative 3, 0. The number of solutions we have in this system is 1. And the name is consistent independent. Just reviewing the names of the systems. So the solution set, if you take this point and plug it into this equation and this equation for x and y, it should make the two of them true. B, we have two equations, the first one and the second one. I numbered them. And the first equation is 8x plus 2y equals 10. And solve this for y. Y equals negative 8x plus 10. Divide by 2. So y equals negative 4x plus 5. So this one has a slope of negative 4. Equation 1 has a slope of negative 4 and a y-intercept of 5. And let's write down equation 2. Negative 4x minus y equals 1. And solve it for y. Negative y equals 4x plus 1. Remember, this moves over to become a plus. Divide, that's a negative 1. We divide by negative 1. So y equals negative 4x minus 1. So the y-intercept of this line is -1. The slope is -4. And we could put -4/1 because we're going to have to graph it. So let's graph the first equation, which has a y-intercept of 5. 1, 2, 3, 4, 5. And the slope is -4 over 1. So we go down 4, 1, 2, 3, 4, right 1. Down 4, 1, 2, 3, 4, right 1. And we draw the line going through those 3 points. Here we go. Lined up. Done. We narrow it on because the line is going on in both directions. And this one, second one, we have a y-intercept of -1, which is right here. And the slope is -4/1, the same slope. Down 4, 1, 2, 3, 4, right 1. And I'm going to go down 4 more. I'm off the page, but let's draw a line going through those 2 points. And what do you notice? Well, it looks like the 2 lines are parallel to each other. In other words, they don't meet. Notice they have the same slopes, different y-intercepts. The y-intercept is 5 and a -1 with the same slopes. So that means the solution set is empty. There's the number of solutions, there's none. And the name of the system is inconsistent. So parallel lines, notice when you solve for y, you have the same slopes, different y-intercepts. So therefore, they're parallel lines and they'll have no solution. Let's continue. Another example, C. We have 2 equations. This is equation 1. This is equation 2. And we write down the first equation, 6x minus 3y equals -9. And we solve for y equals mx plus b. So the 6 moves over to become -6 minus 9 divided by -3. And that cancels, and I get, remember they cancel out 1, 1, so we get 1y. Negative divided by negative positive 2x. Negative divided by negative positive 3. So the slope of this line is 2. The y-intercept is 3. So let's look at the second equation. -10x plus 5y minus 15 equals 0. So we have to solve for y, so 5y equals, the 10 moves over to the right to become plus, the 15 moves to the right to become plus, and I divide by 5. Divide, they cancel out, I get a 1, remember they're 1s, and I get a 10 divided by 5 is 2, 15 divided by 5 is 3. So this equation has a slope of 2 and a y-intercept of 3. Notice that, let's graph, notice that the 2 of them are the same. So I have a y-intercept of 3, which is right here, and the slope is 2/1, so I rise 2, run 1, or if I run out of space, I can go the other way. Instead of rising 2 and going to the right one, I can go down 2 and to the left one. I can go down 2 to the left one. So if you go up 2 to the right, I can go down to the left. And I get these points. Here we go. Draw a line going through these points. Here it is. And notice the 2 equations are different, but they end up to be this slope y-intercept form. Now, in this form, when they're written like this in what you call standard form, or part of a standard form, they're written as ax plus by equals c. Not quite standard form, because the standard form, this one is not in standard form, but in this form, you can't tell if the 2 lines are if the two equations are going to end up to be the same, they're going to give you the same line. But when you solve for y, notice you can get two of these equations. They both end up to be the same equation. So there's only one slope y-intercept of a form for a line. But that line can have many, many equations if you write it in other forms. So this is, the solution to this is one of those equations. So I have to write down 6x minus 3y equals -9. The solution is, you have to write the equation out because there's many points on this line, and for every point that you pick, it'll make both equations true. So it's the equation that makes this true. Now you could write down the answer as y equals 2x plus 3 if you want, or you could write down this equation. All equations are the same, so therefore one of the equations will represent the solution. And the number of solutions is what we say many, or we could also call infinite number of solutions. And the name of this system is consistent dependent. Again, you can't tell with these two equations if they're the same, but when you solve for y, you can tell. And practice. Practice means pause the video, and so you need, there's 3 questions coming on graphs, so you need 3 sheets of graph paper, and you need to work these out. So pause the video, solve the equations for y, and graph them, and see how you're going to do. Here we go. This is number 1. This is number 2. So I'm writing down number 1 first. -x plus 2y equals 4. I'm solving it for y. And I divide by 2. So y equals, that's a 1 over 2x, that's a 1 there, plus 2. Notice when I move the negative over, it becomes positive, and divide by 2. Write down the second equation, 3x minus 6y equals 18. And I'm solving for y. So the plus moves to the right to become a minus, and I divide by -6. So they cancel out, and I get, remember the 2's cancel out here, 1 and 1 give me 1. 6 cancels out to give me 1y, and that's negative and negative positive. 3 over 6 is a half, and 18 divided by -6 is -3. So the first equation, you have a slope of a half and a y-intercept of 2. Second equation, you got a slope of a half and a y-intercept of -3. So let's graph both of these. The y-intercept is 2, which is right there, and we go up 1, right 2. From here, up 1, right 2, up 1, right 2, and we draw that line. Here we go. Done. And now we do the second one. The y-intercept is -3. 1, 2, 3 right there. And we go up 1, right 2. Up 1, right 2. And we draw that line. And even before I did this, once I solved these two equations, I knew that they had the same slopes of a half, but different y-intercepts. So I knew that these were going to be 2 parallel lines before I even graphed them, because they got the same slopes but different y-intercepts. And that means there's no solutions, the empty set. The number of solutions is none because they're parallel lines, they don't intersect. And the name of the system is C-O-N-S-I-S-T, inconsistent. Okay, let's continue. Again, practice, practice, practice makes perfect. Pause the video and work these out. Work these out. Let's see, here we go. And this is equation 1, this is equation 2, and we write down equation 1 is negative 10x minus 5y minus 5 equals 0. Solve for y, negative 5y equals 10x plus 5. Remember, we're solving for y equals mx plus b. So we move the 10 over to become plus, we move the 5 over to become a plus, and we divide all terms by negative 5. That cancels to give me a 1y. 10 divided by negative 5 is negative 2x. 5 divided by negative 5 is negative 1. And if we want to write it down, the slope is negative 2 and the y-intercept is negative 1. Now let's do number 2. 6x plus 2y equals 8. And we're solving for y, so the negative 6 becomes plus 6 plus 8. And we divide by 2. Note the 8 stays, so the 8 didn't change, but the 6 did because it moved to the right. Divide, 2 divided by 2 is 1y. 6 divided by 2 is 3. 8 divided by 2 is 4. And this equation has a slope of 3 and a y-intercept of 4. Notice that these two have different slopes. When they have different slopes, they're going to intersect. So let's find a point of intersection. And the first one, y-intercept is negative 1, which is right there. It is the y-axis. Intercept is negative 1 on the y-axis right there. And the slope is negative 2, so it's a negative 2 over 1. So from here, we'll go down 2, right 1. Down 2, right 1. And we'll draw that line going through those points. There we go. And again, hopefully, it should, when you graph these, hit right on a point, right on one of the square corners here. Because if it don't, you can't get it. You get to solve by another method. And number 2, the slope is 3 over 1 understood, and the y-intercept is 4. So the y-intercept is 4, 1, 2, 3, 4. And the slope is up 3, right 1. So why don't we go down 3, 1, 2, 3, and right 1. If you go up 3, 1, 2, 3, right 1, you probably hit here, but I don't have any point. So instead of going up and to the right, why don't I go down to the left? And we hit this point. Down again, 3, 1, 2, 3, to the left. So up, 3, up, and to the right is the same as going down and to the left. And we plot the line going through those points. But if you've got a big sheet of graph paper, you don't have to worry about that as such, because the points will be there. I just keep them small. So the intersection is this point, x, this point here, x is negative 1, and y is 1. So x is negative 1, y is 1. And the number of solutions is 1, and the name of the system is consistent independent. Because the slopes are different, we have one point of intersection. And we have another one to do now. Let's see what we have. We have equation 1 and equation 2. So we have negative 3x minus 2y equals negative 10. Negative 2y equals 3x minus 10. And we divide by negative 2. Y equals negative 3 over 2x plus 5. And we got the second equation is 12x equals negative 8y plus 40. This time the x is okay. The y has to move to the left to become positive. And the 40 is on the right is okay. Don't change the sign. And we move the x the other way now. I'm just trying to be consistent here. The y goes on the, I could have moved the y to the left and the x to the right away here, but I did it one at a time. Now I divide by 8. 8 cancels negative 1y, and 4 and 8 goes 2. 4 and 12 goes 3 and is negative. 40 divided by 8 is 5. Note the two equations have the same slopes, negative 3 over 2 and a 5. Negative 3 over 2 and a 5. So they are the same lines. So let's graph these first. The y-intercept is 5, 0, 1, 2, 3, 4, 5. And I go down 3, right 2. Down 3 because it's negative 3, to the right 2 because it's plus. Down 3, 1, 2, 3, right 2. Down 3, 1, 2, 3, right 2. So drawing a line that goes to these points. Remember, the two equations are different, but they end up to be what? The same. These two equations are different, but they end up to be the same slope by intercept form. So there's only one line. That means that you have to write down one of the equations. So you can write down this equation, you can write down this equation, or you can write down this equation. So if I write down the first equation that I was given, which is this one, number 1, then that's because all the points that satisfy this equation also satisfy this one or satisfy this one. So one of these three equations, your choice, that one, or that one can go here. The number of solutions is called many. There's many solutions. There's an infinite number of points that lie on a line. So since the two equations are the same, and this is representing those, so there's an infinite number of points on a line. And the name of this system is consistent dependent. And that brings us to the end of this video. Hopefully you know how to graph. Hopefully you know the names of the systems. Remember, memorize it, learn. Parallel lines is an inconsistent system. If the slopes are not the same, then the lines will intersect and you'll have a consistent, independent system. And if the two equations end up to be the same, then you have many solutions. The equation is the solution, and you have a consistent, dependent system. If you like my video, click the like button, the subscribe button, the notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel. Thank you very much for viewing my video. Bye-bye.